Dear friends, in this video I'm going to explain how to calculate Gibbs free energy for hydrogen evolution reactions. This is the important reference paper for hydrogen evaluation reaction. If you are doing hydrogen evaluation reactions, so you can consider this paper for reference. So in this slide, I will explain the basics of hydrogen evolution reaction. The hydrogen evolution reaction under acidic condition involving three elementary reaction steps shown in R1 to R3 and visualized in following figure. So in R1, hydrogen atom will absorb on the metal surface. In the R2, the second hydrogen atom interact with this absorbed one leads to form hydrogen. This is the Volmer-Hierarchy mechanism. So R3 is, so the second hydrogen will absorb in the metal surface and interact, both of them will form hydrogen molecule. This is Volmer-Tafel mechanism. So this is the Volmer-Tafel mechanism. This is the Volmer-Hierarchy mechanism. So hydrogen absorption energy descriptor for the hydrogen evolution reactions. According to the Sabatier principle, the optimal binding energy of the reactant should not be too weak or too strong. If the binding energy corresponding to 0, then hydrogen atom will both easily absorbed on the metal and dissolved as a hydrogen gas. So in this slide, I'm going to tell you how to get experimental zero point energy and entropy from database. So if you want to, this is the small table. I have calculated the energy of H2. This is the calculated zero point energy, experimental zero point energy. This is experimental entropy. So if you want to get experimental values, so you go to the NIST database. You can search the H2 molecule. You will get these things. From this first table, you will see the entropy of the H2. So here is 130.68. The second table is showing the vibrational frequency. Here you see the harmonic vibrational frequency 4401. So first you will see the calculation of entropy. So you can add entropy with this value. This is the conversion factor of EV. So multiply with this value, then multiply with the temperature. You finally get the entropy 0.40. Okay. So then you can calculate the zero point energy. This is the formula for zero point energy calculation. So this 4401 is the vibration frequency of the H2 molecule. So divided by 2, you will get this one. Then you can convert into EV. So finally you will get 0.27. Okay. So in this slide, I'm going to tell you where I used to convert the energies. You can go to the colby.edu chemistry, this website. You can find this kind of table. So just add your values here and click enter. You will get the corresponding converted value for other units. So we want only electron volt, we used 0.27. So in this slide, I'm going to tell you how to calculate the hydrogen absorption free energy. So experimental zero point energy of HT is 0.27. We already calculated. So in order to get that exact 0 point energy of the absorbed hydrogen on the metal surface, so you need to subtract with the calculated 0 point energy with half of the experimental 0 point energy. If you subtract with 2 energy, you will get the exact 0 point energy. Okay. Then the entropy of the absorbed hydrogen atom is almost 0. Okay. If you calculate DFT, you may not get it, or you will get 0.00 something, so almost 0. So for that case, we have to consider the experimental 0 point energy for calculation. So this is the experimental entropy of the H2 is 0.41. So we have to take off of the value. For that, the entropy of the absorbed of hydrogen atom is minus 0.205. So if you subtract with this value and this value, you will get the 0.240. So using this value, we can finally get the hydrogen absorption free energy. So this is the energy of the hydrogen absorption. So this two value we already calculated here, this 0.240. So if you add these two value, you will get the exact binding absorption free energy of the platinum surface on platinum surface. Okay, if you see this is the platinum surface, you will see this is the 0.09 minus. Okay. Thank you for watching my videos. So thank you for watching. Please subscribe my channel and like and